Hey guys, in this video we're going to look at solving some quadratic equations using graphs. And so the first example, it says to solve this quadratic equation by graphing x squared equals 1. And so what we do is we set each side of the equation as its own function. So in other words, we will graph something like f of x equals x squared, and then we will graph f of x, or actually not f, let's call it g, a different function, g of x, equals 1, and then what we're going to do is see where the two graphs meet. So here's what we're going to do. We're going to first graph x squared. So x squared has vertex at the origin over 1 up 1, over 2 up 4, over 3 up 9, but we can't do that. And so we're going to now connect the points, smooth it out. Okay, so that is f of x. G of x is a line constant of 1, which means it's going to be a horizontal line that goes through the y value of 1, and it's going to look like this. So that would be g of x is equal to 1. Now what we want to do is figure out where the two curves meet, and we see that they meet here and here. Well, when you solve the quadratic equation, these 2 points, all you need are the x values where they meet. And so they meet at the x value of -1, and they meet at the x value of +1. So we would say -1, comma 1 in curly brackets, because it's a solution set. Now here's the alternative way to do this. Alternatively, what you can do is you can take your equation and move everything over to the left until it's equal to 0. So if you subtract 1 on both sides, you would get x squared minus 1 equals 0. Now this is what most people do all the time. This function is going to be the regular x squared function and then drop down 1. So its vertex is going to start here instead. Then you're going to go over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 9, but we can't fit those on there. And so we're going to connect our points. And now you try and see 0 where they cross the x-axis. So if you can get this equal to 0, you just have to look and see where the curve, just the one, crosses the x-axis, because that's where y value is 0. That's where this will be 0. So it's still going to be at -1 and 1. So no matter which way you do it, -1 and 1, ooh, look what I did. -1 and 1 are going to be your two solutions, no matter what. So I'm going to do it both ways for a while. This one, x squared minus 4, x squared, and then minus 4 drops it down 4 units, over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Connect our points. That. And we're trying to figure out where that's 5. And so here's 5. And so right here, let me use a different color. So right here and right here are where both of those y values are equal to 5. Then we look at the corresponding x values where that happened. And it happened at 3 and -3. So our answers are going to be -3 and 3. So in curly brackets, -3 and 3 are the two solutions. Now, if you go ahead and do it this way, if you add 4 to both sides first, you would get x squared is equal to, what's that, 1? You could do it that way, couldn't you? But really what I want to do is I want to get this equal to 0. So let me start over again. X squared minus 4 equals 5. What if I subtract 5 from both sides? I would get x squared minus 9 equals 0. Now if I did that, I'd have to drop it down 9 units, wouldn't I? And I don't have enough graph for that to drop it down 9 units and then show it going upward. And so that would be a problem for me. So in this case, I might want to just go ahead and stick with the original way I did it, which was just sticking with the original one and then just working with it this way. graph the left side and then see where it equals 5. Because you can do it either way. It just depends on the graph you have, and it depends on the function. So let's take a look at this one. This time, we want our function x minus 1 is going to shift the vertex 1 unit to the right, and then minus 3 is 3 units down. Okay, there's a 1 in front of the parentheses, so it's over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Just smooth it out. Okay, we're trying to figure out where that equals negative 2. So here's negative 2, and it occurs at what x values? It looks like 0 is 1, and this one would be 2. So it looks like when x is 0 and x is 2, you get the two y values of negative 2. So we're going to say 0 and 2 for our two solutions, which means if you plug these two numbers in here for x, you will get a true statement. That will be a true equation if you plug those in. Well, let's try it the other way. If you take this and add 2 to both sides, let's see what happens. We get x minus 1 squared. Negative 3 plus 2 is negative 1 equals 0. Okay, well, let's see what this looks like. X minus 1 still moves it 1 unit to the right. Minus 1 is 1 unit down. Okay, over 1 up 1 still. Over 2 up 1, 2, 3, 4. And then over 3 up 9, but we can't fit that 1, can we? So we're going to go ahead and connect our points. All right, now we want to see where it equals 0 this time. But we see that it's still 0 and it's still 2. Those are the x values where this function equals 0. So we still have the answers of 0 and 2 no matter what we do. So we could have done this one both ways. Here we have one that's already equal to 0. Now, if it's already equal to 0, then you really don't have a choice. You kind of just have to let it equal to 0. So this one, we're going to take our vertex, we're going to shift it 2 units to the left. It does not move up or down, so there's our vertex. We're going to go over 1 up 1, over 2 up 1, 2, 3, 4. And that's pretty much it. We'll connect our points like so. And we want to figure out where our curve is equal to 0, and it appears to be at only one location, and that's negative 2, right where the vertex is. Really what they call that is a double root. There's really 2 of them, and they're both negative 2. But when we report our answer, we just report the single value of negative 2, and that's it. Normally you have 2 answers, but if they're the same number twice, then you just report one of them. All right, with this one, this time we have negative x squared plus 4 equals 3, so we're going to take our function, we're going to move it up 4 units. It does not move left or right. It does flip down, so over 1, down 1. Over 2 down, 1, 2, 3, 4. Over 3 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we smooth it out. Okay, and where does that equal 3? Well, here's 3, and it looks like it equals 3 at the x values of negative 1 and 1. So negative 1 and 1 are going to be my 2 solutions to this equation. Negative 1 and 1. Let's see if this works the other way. If we subtract 3 from both sides, we get negative x squared. 4 minus 3 is plus 1 equals 0, which means we would shift it up 1 unit, still down. So over 1 down 1, over 2 down, 1, 2, 3, 4. That's it. And then now we just have to see where it equals 0, and we still see that it equals 0 at negative 1 and positive 1. So we still have the same 2 answers of -1 and +1. All right, next one. Okay, so now we're going to move our vertex 1 unit. Let's see, that's going to be to the left, and that's it. It's not up or down. There's a 1/2 in front, so which means all of our previous values get cut in half. So over 1 up 1/2. Used to be over 2 up 4, but now it's going to be over 2 up 2. Used to be over 3 up 9, but now it's going to be up 4.5. 1, 2, 3, 4.5. That's all we can fit on there. We see that it did get wider, like it usually does when you have a number in front that is between 0 and 1. And we want to figure out where that equals 2. So where does that equal 2? Here's 2, there, and there. So these 2 points right there are the ones we're going to focus on, and that's going to correspond to -3 and +1. So my two answers are going to be -3 and +1. So now let's look at this the other way, setting it equal to 0, which, like I said, that's really what most people do. If you set equal to 0, you'd have to subtract a 2 on both sides, which means we now have 1/2 x plus 1 squared minus 2 equals 0. So we're going to go 1 unit to the left and then 2 units down. And now we're going to do our graph. Over 1 up 1/2, over 2 up 2, over 1, 2, 3, 1, 2, 3, 4, 5.5. We're going to connect our points. And the job now is to figure out where it equals 0. 0 is just a little easier to look at. So we see this -3 and +1, and those two values were the exact same ones we got before, -3 and +1. Now I don't mind how you do this. You can do it like this, or you can do it like this. It's completely your choice, but you have to get -3 and 1 as your final answers. So I'm giving you the option of doing either one. Okay, this one, we're going to first do it the regular way. We're going to move it 2 units to the right and then down 4. Okay, you do have a 2 in front, so it's going to be over 1 up 2 this time. Used to be over 2 up 4, but now we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8, and 8. It's narrow, and it definitely looks narrower. Connect our points. Okay, where is that equal to -2? Here's -2. So it looks like here and here are the 2 points that we need to focus on, and that's going to correspond to 1 and 3 for the x values. So 1 and 3. All right, so let's try it this way now. This time we're going to add 2 to both sides. And now we have 2, x minus 2 squared. -4 and 2 are going to make a -2 equals 0. So we're going to go 2 units to the right and then down 2. And then we're going to, again, go over 1, up 2, over 2 up. It used to be 4, but now it's 8. It's going to put us all the way at the top. Okay, I'm going to connect our points. And if we set it equal to 0, we're actually looking to see where it crosses the x-axis. And that's going to be at 1 and 3, just like it was before. So we still get the answers of 1 and 3, no matter what. Okay, here we have 3x squared is equal to -1, so let's try that one. 3x squared is going to start at the vertex at the origin, over 1, up 3 this time. It would be over 2 up 4, but 4 times 3 is 12, and we can't do that. So we're going to have to be satisfied with this. All right, and we want to know where that equals -1. So where does it equal -1? It doesn't really look like it equals -1 anywhere. So what's going to happen then is that here's -1 right here. And actually, let me go ahead and graph that line. So -1 looks like this. Okay, they don't meet at all. And so since they don't meet at all, it's going to have no solution. There is no x value, real x value you can plug in for that makes that a true statement. Later on, there will be a solution, but it won't be real. It'll be complex. Okay, let's try it this way. So if you add 1 to both sides, and you get 3x squared plus 1 is equal to 0, and you shift it up 1 unit, and you go over 1 up 3, and you smooth out your curve like this. All right, you still see that 0 right here, the x-axis now, which is easier for some people to look at, it never touches the x-axis. And so therefore, those two curves are never going to meet, and they still have no solution. Or you can use the empty set symbol. All right, here's our next one. This one we have x minus 3, so that's going to move it 3 units to the right. Minus 1 is 1 unit down. You do have a 1 in front, so it's over 1 up 1. Over 2 up, 1, 2, 3, 4. It's over 3 up 9. That's too much. We can't really do that. So all right, so where's that equal to 2? So this time I'm going to actually put that line on here. So here's 2. And now we have our first issue. And that issue is it does not cross at a nice lattice point. So what happens is we just have to report the 2 consecutive integers for x that is between. So we definitely have 1. It would be about right there, wouldn't it? Between 1 and 2. There's definitely going to be a solution between 1 and 2 somewhere. So between 1 and 2. And then we also have 1, it looks like between 4 and 5 right here at this point. So we're going to say also between 4 and 5. So if you solve it by graphing, you can't really tell exactly what the values are, which is why we're going to have other ways to solve these so we can get an exact value. Okay, same thing for this one. If you subtract 2 on both sides and move it over, you would get x minus 3 squared minus 3 equal to 0. So that would still move it 3 units to the right, down 3 units this time, over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 9, which actually you can fit this one on here. Okay, then we connect our points. And sketches are sometimes hard to do, but I think this one looks pretty good. And where is it equal to 0? Again, we see that one of them is definitely between 1 and 2 right here, and another one's definitely between 4 and 5 right there. So we're going to have the same 2 answers that we did on this one, between 1 and 2 and between 4 and 5. Between 1 and 2, between 4 and 5. Okay, our last example. See what happens with this one. Okay, so this one, we have x plus 1, so that's going to go 1 unit to the left, 6 units up, and then it's going to get flipped down. And so that's going to be, and it's down 1, negative 1, so down 1 over 1, over 2 down 4, and over 3 down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's usually the last ones you can get on there. All right. Okay, so where's that equal to 1? Well, let me put 1 on there and show you. Here's 1 for y. So we're trying to figure out where that equals 1. And again, it looks like we don't have any nice numbers again. So it looks like it's between negative 4 and negative 3, right there at this point, between negative 4 and negative 3. And then we have another one between 1 and 2, it looks like. And then don't let that bother you, because later we will be able to find exact solutions. So if we move everything over, let's see what happens this time. Negative x plus 1 squared. That would be now plus 5 equals 0. So we'd go 1 unit to the left of 5. Okay, still over 1 down 1. That hasn't changed. Over 2 down, 1, 2, 3, 4. Over 3 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then we connect our dots. Except this time we get to look at the x-axis, which is a little bit easier to look at. And so we see again, we have one solution between -4 and 3, just like before, and the other solutions between 1 and 2, just like before. So this has been solving quadratic equations graphically. Remember to like my video, subscribe to my channel if you haven't already. We'll see you guys later. Bye.